This is a question from CSIR NET 2023. Sequence real analysis, sequence and series. The question says that under which of the following condition is the sequence xn of real numbers convergent? The subsequence x2n plus x2n x3n are convergent and have the same limit. The subsequent x2n plus 1 x2n x3n are convergent. The subsequent xkn are convergent for every k greater than or equal to 2. Limit n tends to infinity, xn plus 1 minus xn is equal to 0. Okay, we will here use 2-3 results. First of all, let xn, let us take a because xn is using the question. Take a. Let an be a sequence of real number which converges to L. Then any subsequence a and k denoted by this also converges to L. And the second result is if even and odd terms of a sequence converges to same limit, then the sequence converges. Then the sequence converges. Okay. The first part we are given that x2n plus 1, x2n and x3n all converges to same limit. All converge to same limit or just given all are convergent at the same limit. So these are the odd terms and these are the even terms. So from the previous result, xn will converge in this case. Now consider the second part. The subsequence x2n plus 1, x2n, x3n are convergent. Only we are given that they are convergent. So we are given that x2n plus 1, x2n and x3n are convergent. So assume that x2n converges to L and x3n converges to M. Now how does x3n look like? X look like this: x3, x6, x9, x12 and so on. Consider its subsequence: x6, x12, x18 and so on. Just taking even terms from here. This will converge to M2 because every subsequence converges to the same limit. It is a subsequence of this and this converges to M. Note that this sequence is also subsequence of this is of this. Also this is also subsequence of x2n, as these are all even terms. So this also converges to, so this sequence x6, x12, so on also converges to L because it is a subsequence of this, and it converges to M as the limit of a sequence is unique, thus L is equal to M. So we have shown that x2n converges to L and x3n also converges to L. Now consider x3, x9, x15, yes, and so on. I'm taking the odd terms from here simply. This is a subsequence of x2n plus 1 odd terms, all the odd terms, the subsequence of this. So if this converges, it is given converges to A, so this must also converges to A. But from this, it is also subsequence of this. This converges to L2. Thus, L is equal to A. Hence, x2n plus 1 also converges to L because it converges to A, and we have shown that L is equal to A. And x2n also converges to L, so odd and even converges to the same limit point, thus xn converges to L. Hence the sequence is convergent. So in this case sequence converges, in this say sequence converges, we need to check this. Now we come to the third case. Third option says that the subsequence xkn, where n belongs to natural number and k is greater than or equal to, are convergent. We are not given they are saying convergent, but they are convergent. So question is this convergent or not? And let's just make an example. Let us take a sequence. Let us define a sequence xk such that it is equal to 2 if k is a prime, and it is 1 if k is not equal to prime. Okay, then I want to show that this sk satisfies this condition. Let's make it n because m, because we have used here k. For the sake of confusion, let's make it m if m is equal to prime, if m is not equal to prime. So now how does it look like? 1 is not a prime, 1 2 2 1, like this. It keeps on going like this. I will show that this will satisfy this condition. Let us take k is equal to 2. Then how does x2n look like? It's all even terms. It is x2, x4, x6 and so on. So only this is prime, so this is 2, and these are not prime, so this is 1 1 1. This is a convergent sequence. This is a convergent sequence. Okay, so let us take one more example. Let us take let me rewrite the sequence as is 2 if m is equal to prime, 1 if m is not equal to prime number, of course. So let k is equal to 3. Then x3n, how does it look like? It look like this: x3, x 6, x9, and so on. So how does this sequence look like? This is will be 2 because 3 is a prime, this will be 1, this will be 1, this is 1. Again, this is convergent. In general, for any k, we have xkn. How does it look like? It look like xk, x2k, x3k, and so on. So if k is a prime, then there is a possibility 2 or 1. Otherwise, this can never be a prime. This is never a prime. So it will be always 1, 1, 1. So for any k belongs to natural number, this will always be eventually 1, 1, 1, 1, 1, 1 sequence. So it is convergent. Always. So we have shown that xkn is convergent for all k greater than or equal to 2. Now again, the how does sequence look like? Xm was 2, m is equal to prime, 1, m is not equal to prime. So we have an example of a sequence which satisfies this property. Now question is xm is convergent or not? You can simply see that it look like 1, 2, 2, 1, 2, 1, 2, and so on. There are infinite 2 because there are infinite prime. They are infinite prime. There's infinite 2. There is infinite 1 because they are infinite non-prime. So it can never converge. Xm is not a convergent sequence because there are only two possibilities for convergence. Either it converges to 1 or it converges to 2, but it has infinite 1, infinite 2. It can never be convergent. There is always, you can find 1, 2, 1, 2. It will oscillate between 1 and 2. So therefore, we can say that this, in this case, this is not convergent. Now we need to check the fourth option. Fourth option says that limit n tends to infinity, xn plus 1 minus xn is equal to 0. Okay, is this sequence convergent or not? We can find an example such that xn, how do we construct this? Let it be 1, let it be root n, then xn plus 1 minus xn is equal to root n plus 1 minus root n, which is equal to n plus minus n root n plus 1 plus root n, which is equal to 1 by root n plus 1 plus root n, which tends to 0 as n tends to infinity, because this term will go to infinity and this tends to 0. So we have an example that such that xn minus xn tends to 0. But the sequence, this is not a convergent sequence, as xn tends to infinity as n tends to infinity. So xn is not convergent. Thus this is also true. So first and second option are correct.